All right, folks, let's get started. I hope you had a good set of breakout panels. We're back to the plenary, and it's good to see you all back here. This being MIT, I owe you a small apology for the Star Trek fans out there. Apparently, I said Vulcan mind melt, and apparently, I have no recollection of this, I said Star Wars. I apologize. I really do. Dr. Spock, Mr. Spock, lived just down the street from us and passed away, as you know, recently. So in his, I'm sorry? Yeah, exactly, he lived, and so in his honor as well, I apologize. So as you know, we have these three panels, and I'm moderating all three. And the first panel is the future of the university. This one is about professors. It's the future of faculty. And we have three really wonderful, and again, very senior and decorated faculty members participating. And once again, just to remind you, the reason we're doing these panels is because we received a lot of questions about, or inquiries about, hey, what's MIT doing about this stuff? So I have the honor of really wonderful colleagues being willing to come and share. So our panel today has, I'm going to change the order just because of the order of the speaking. Professor Dave Darmofal, a good friend. Dave is a Michigan man, and then he got his master's in PhD at MIT. And he's also both a Bose award winner, which is one of our highest teaching awards, and he's a MacVicar fellow as well. And he's a very well-respected and pioneering teacher. He flipped the classroom really before the term existed. And in his spare time, he is also one of the world experts in computational fluid dynamics and numerical methods. So first, Dave. The next speaker after that is another dear friend and colleague, Professor Hazel Sive. Hazel was Associate Dean for Science in the School of Science until recently. She is a graduate of Witwatersrand from South Africa and got her PhD at Rockefeller. She's also a MacVicar fellow. And Hazel is special also because she is the co-chair, along with me, of the Faculty Advisory Committee of MITx. So all our MITx courses go through a Faculty Advisory Committee. A lot of our policies go through that committee, and she co-chairs it. And it's been a real font of wisdom for us in navigating what has been a tricky territory. But also, Hazel cares deeply about international, especially Africa. She is from South Africa, and she cares and leads up the Africa group at MIT that's looking at a number of issues related to education in this wonderful and very rapidly growing continent. Our third speaker is Dean Christine Ortiz. She is a professor in the Department of Material Science. Christine got her undergrad at RPI and her master's and PhD at Cornell. She, again, in her spare time, is one of the world authorities on biological structures and on exoskeletons, on skeletons, structural mechanics, nanomechanics, and so on. And while she's not writing papers for Nature, she is also contemplating fundamentally rethinking the university. And she recently announced that she would be stepping down and starting a new educational establishment in her copious spare time. So with that, I'd like to kick off the panel. I've asked each panelist to speak between 5 and 10 minutes, with or without slides. Although we are the Office of Digital Learning, we don't necessarily love slides. So I'll ask Dave to kick it off. Dave?
Thank you. Here or there? Anywhere. I'll try here and we'll see how it goes. So no slides today, just some notes that I'm going to try and use to organize myself. I thought what I would do would be to focus on the role of faculty mostly in on-campus subjects. And to give you the punchline of what I'm thinking about this, I actually don't think the role of faculty will change that much in terms of what are the main goals, the objectives that a faculty member has in helping students learn. But what we do to make that happen, certainly I do think will evolve. So I've outlined a handful of things that I think are critical for the faculty in terms of on-campus subjects, in quotes here. And I'll expand that a little bit more. So the first thing, and I know all my friends in the teaching and learning lab are always happy when I say this, is to actually think about what are the things that you're trying to have the students learn, learning objectives. And this, just by way of example, Sanjay mentioned that I got involved in teaching and flipping a classroom before the term flipping actually existed. So this was back in 1998. I was a fairly new faculty member, co-teaching a junior-senior level subject in aerodynamics. So I'm in the aero-astro department. So this is a course which about 2/3 of our students will take. It's an upper-level technical elective. Students have to choose like 4 or 5 of them. And most students want to learn more about how airplanes fly, so we get a large number of those students in our department will take the course. So the two of us I've taught a course like this before I got here. The other professor had been teaching it for years. We thought we had done a reasonably decent job in our role as instructors. And towards the end of the semester, we said, well, let's write an exam that's really we're gonna really see how well the students have learned this material. And we're going to in particular emphasize synthesizing different concepts that they had seen throughout the semester. So we're going to draw this from there, that from there, and they were going to somehow realize that all of these things somehow tied together and they could solve a problem that synthesized multiple concepts. Now, the problem is we really never taught them how to synthesize concepts. We taught them this concept, and then we'd stop and we'd teach them the next concept, and then go on to the next one. But no real synthesis. We did have, the classroom at that time, the subject was structured much like you would expect, typical engineering course, at least at that time, which was we'd have about weekly problem sets. We had one small project towards the end of the semester that was about a 2-week-long project done with a couple of people, so a little bit beyond the usual piece set, but not much more than that. And a midterm exam, and now this was going to be the final exam. So we gave the final exam with all of these great synthesis questions, and we thought, yeah, this was going to be great. They're going to be able to do this. About 2/3 of the way through the exam, the students are still writing and writing and writing, or some not writing, just sitting there going like this. And exam ends, and we've got students coming up to us very distraught, saying, oh, I did terribly on this exam. Other things that were coming out were not just that they had done terribly, but they were saying, I feel like I should have been able to do this, but I could not. And then we had to sit back and reflect on what was happening. And it was easy to see what was going wrong, which is we really value this synthesis ability, but we were doing next to nothing to actually help our students gain that ability to synthesize concepts. We were teaching these concepts almost separated from each other. And so this kind of deeper level utilization of conceptual understanding was not something we were working on. And if the problems didn't look like an epsilon away from the problems that they had done in the problem set, they were not going to be good at solving these problems. So that's where we started saying, all right, what are really our objectives? And our objectives weren't just let's have students have the ability to estimate the drag due to wingtip vortices. It was to bring all of these concepts together and solve problems that aren't just the ones they've seen before. And as much as anything, that's when we started to then say, well, look, the content doesn't matter as much. We got a lot more flexible with exactly what the content is because we've started to realize our goal here is teaching students, helping students to become problem solvers. And the content is sort of the window dressing at some level. It's not completely, but so we wrote down our objectives, and right at the beginning, those objectives included problem-solving capability that we had not really emphasized in the past. So anyways, lesson number 1 for us was write down what you really want students to be able to do, and then focus your classroom efforts, the structure of your class to make that happen, hopefully. So we started that revision, and I'm going to tell you a little bit more about some of the changes that we made. The second part, so number 1 is learning objectives. Second thing that I think about the role of the faculty, nothing new, is to provide an environment that's appropriate for student achievement of those learning objectives. And by that environment, I really mean everything. So that might be the sources of knowledge that the students might go to try and learn, help learn from, so textbooks, ebooks, MOOCs or MOOC equivalents, notes, handwritten notes, whatever they are, videos, media, the list goes on and on. Maybe even lectures, actually, they might learn from a lecture as well. So one option, knowledge sources. Another, practice opportunities, problem sets, projects, presentations, whatever makes sense to give students the opportunity to practice. Formative assessment opportunities. It's not just enough to give practice problems, but you need some reasonably authentic way to have students assess their understanding. Now, one of the ways is you give them a problem set, you give them to graders, graders grade their problem sets, but now that's like 2 weeks after that they've been seeing the material, that they're getting some feedback. So one of the great things about more modern capabilities is the ability to cut that feedback loop down. But nonetheless, formative assessment that students can use to help gauge their own understanding of the material before it's too late. So what did we do in this class after we had this problem with conceptual understanding? One was the textbook was still there, but we started to flip the classroom. We used look-ahead problem sets in conjunction with the textbook reading. So we gave problems that were not something we had discussed in class. And then what we did in class, leveraging that, was we started to focus in on conceptual understanding, on synthesis, these other things that we wanted to achieve. But when they came to class now, they had some basic knowledge that was starting to form. We could help clarify that for them and go deeper. And so this look-ahead or flipped classroom structure was really important for us so that they could have a vocabulary. They could do some things that they don't need us to do on a board and a lecture environment, and then we could leverage that and really take advantage of being in a room together. So we flipped the classroom, the textbook stayed the same, we had look-ahead problem sets, and then we focused on active learning. We also had a semester-long project that we built into the entire semester that focused on integrating these different concepts as well, so another way to bring synthesis into the picture. What happened when we did this? So it turned out the very first year that we did this, the look-ahead problem sets that we had were fairly superficial. They were the equivalent of what you might call a reading quiz. You could really quickly skim the material and probably do fine on these. Didn't really do anything for the student learning. What we then did after that, the next year, was we went to a full-bore problem set, very difficult problems, the way we would have done them in the after-the-fact usual situation. That's required students to really dive into the material. That year, we got significant improvement in learning. A couple years after that, we did the same exam that we had students performing poorly at, and we had statistically significant gains in understanding, and subject evaluations actually improved. One of the neat things was our lecture performance improved according to the students. In that 1 year period, going from reading quizzes to difficult look-ahead problems, and we didn't really change the lectures, it's just that the students came in more prepared to have a useful experience in lecture. And so another major lesson for us. Real quickly, what we've been working on now is we've developed a MOOC. If you go on to edX, MITx, it's 16101X. That's got the same material that we teach in this course as well as a precursor to this course. And the question we're struggling with now is how do we use this material? What's difficult about this is we've got hundreds of problems in this 16101X. Each of the problems has videos, solution videos, kind of con-style videos of just me talking about here's how we solve this problem. If you add up all the hours involved in someone like just listening to all of those videos, it's the equivalent of all the time they would have spent in lecture already. So now how does this work? We've got this rich resource, what I think is a rich resource, but you're requiring them to basically spend twice as much time as they already do to actually really use that resource. And that's a problem we're still struggling with and trying to figure out how to leverage these materials that allow them to do formative assessment, many practice problems, et cetera. So last thing I wanted to mention is something that I'm a little bit concerned about, and I think we need to do better in terms of education, and that's sustaining best practices, sustaining the use of best practices in education. What do I mean by that? I think places like research universities like MIT and others are great at innovating. That's the culture that we live in. what we're not great at is sustaining whatever that innovation is. If you think about our research careers, they typically are, we're going to work on this problem, we're going to solve this problem, we're going to make a huge impact, and then 5 years later, we're on to the next problem, and we're on to the next problem. But what would it be like if we said, well, let's take what you just did and make sure that we're using this for the next 10, 20, 30 years, whatever it is. Or even more difficult, let's use that research best practice that someone else invented and it's been shown to work and bring that into our curriculum, into our pedagogy, and make sure that gets sustained. I think we've all seen educational best practices either developed locally in your own university or by someone else, gets applied by someone who's very excited about doing it, but then how do you sustain that when the next faculty member walks in? And I think that's a really important role of the future faculty, is figuring out how to sustain these educational innovations and best practices, especially when they're not coming from your own home, basically. So with that, kind of summarizing, roughly speaking, I look into the future and I think that, yes, all of these things, learning objectives, formulating a learning environment, assessing learning, are going to be the same as the same objectives. I think we'll do them differently as time evolves. A fourth bullet would be, how do we actually sustain educational best practices? And I think that's an important role, as much as these other things are in the future of the faculty. So, thank you.
Quick question for you, Dave. You've taken a very engineering approach in your department, course 16. By the way, everything at MIT is numbered. I'm number 74. What's your number? No, I'm just kidding.
Yes.
The departments are numbered, the buildings are numbered. We don't use names, because we're MIT. Course 16 is aeronautical and astronautical engineering. Do you think, would you say that this belief is widely held within the department?
Which is the
belief that we need to sort of upgrade our pedagogy and then we need to sustain it?
Good question. So I think one of the things that we're in the middle of now is trying to ask questions again about how well our students are really achieving what we think they should be doing. And we've started to look carefully at both what they look like when they come in as sophomores to our department, as well as what's happening each year. And so that to me is an important part of this, and that's, we tend to like evidence. And so as much evidence as we can bring to the table, and generally what we've been finding is the learning isn't where we want it to be. Students aren't capable of the things that we'd like to see them be capable of. And then when you start getting those answers back, I think you get people motivated to try and solve problems. So where we're at right now in our department, I would say, is really looking deeply and trying to ask questions about our students really achieving.
There was a question in the earlier panel that, the faculty, is it hard to change faculty? I'd say at MIT, generally, evidence does make a difference, right?
Right, and so if I go back to your original question, I would say some number like half of the faculty right now in our department would say there are real problems, and the other half would say either no, there aren't problems, or that necessarily they're not problems that we can quite solve. They're larger scope than just what a department has. I don't quite believe that, but I think bringing evidence to the table is a way to start saying, look, we have to pay attention to these problems.
And you're ranked the #1 department in the world in graduate in aerospace?
Yes.
And you're still pretty insecure about it. That's awesome.
Very insecure.
Thank you.
Yeah.
So with that, thank you, Dave. I'd like to now move on to Hazel. Hazel, when she, as I said, is not studying neurological disorders in zebrafish, which, by the way, I was tempted to say, can you talk about that as well? Because I'm very curious about it. Thinks a lot about the role of faculty members generally. Hazel?
Yeah. Awesome. I'm actually going to use the podium. Thank you, Sanjay. So maybe I'll do that. Thank you. It's a real pleasure to have this small time to speak with you and the honor of speaking at this terrific meeting. I do think about the faculty a lot. I think about the faculty as educators a lot. And in putting together some slides, I thought, we could go some places that you've discussed already today, and some things that Dave said really will resonate from my presentation. And then let's go to some personal things that I'm doing to address the future of the faculty. I think, and Dave reiterated this, that there is a kind of unchanging core role of the faculty. I think the faculty and the students are the core of the university, and the role of the faculty in this position is to discover the field, of course, the research aspect, and then the rest would be the education. There's the service part, but we won't discuss that right now. Explaining the field, and then challenging students. And I think the other thing that is just, for me, so important is guiding students, encouraging students. I would say if there's one thing that I think is really important to me in dealing with students, it's encouraging them. The rest kind of follows, you know? But within this unchanging role, which I don't see changing except in its particular form, I think the university is evolving. And I think universities always evolve, and I think that's the power of universities, that they can evolve. One of the things that we are not is a government. We don't have rules. We don't have law. We have rules. We don't have laws. We have rules. We have policies. And those policies, and this comes back to something you said, Dave, are hard to actually turn into sustainable practice. They're hard to turn into laws, and that's a downside, but the positive side is that evolution, change, is really feasible, and it's how universities perdure, and it's how things move and stay fresh over time, over hundreds of years, over even more, 1,000 years for some universities. What I think about as listed is how, when, and where do we educate? And I've been thinking quite a lot about faculty as global educators, both through things like edX courses, MITx courses, but also as part of a kind of a global academy where we can engage our colleagues far away as though they were part of the MIT faculty. And for me, that is a wonderful thing. But I'll come to that in a moment and tell you what I'm doing in that sense. I think about students evolving. You know, I teach next semester a course in graduate development, and I used to teach this course in such a way that we would start off with a puzzle in developmental biology. How do two groups of cells come together and go on to do something completely different, make a heart or make a brain, in a way that a single group of cells would not be able to do? And the answer is that they interact with each other. That is a classical problem in developmental biology. But it's interesting over the years, when I posed that question to my students, the answer started to change. It used to be 20 years ago that the students would answer, oh, the cells interact. But now they answer, oh, the cells are sending out signaling molecules, and they're engaging in signal transduction, and there are changes in chromatin structure, the molecular details that actually describe the cell interaction. And I realized that my students had evolved, and they were starting the course with a different knowledge base. And I thought that was very interesting, and it's made me change the way that I've taught my course. Of course, the other thing that's evolved for students is that online is baseline. And the thing that you've discussed and that we are thinking about is that the degree track is much more fluid and is going to become more fluid. Students will go, will come, and the accumulation will give them their degree. But of course, students stay the same, and I think that that's really important. They're always searching for what they're going to do next. They're always searching for guidance, and they are excited to be challenged, although sometimes overwhelmed if the challenges are not phrased properly. So I really like this notion of thinking about students both as evolving, but also as staying the same as human beings, and the role of the faculty to engage those new and the same human beings. And then at the same time, you know, we can think about teaching as evolving, of course. Easy to use online tools. You know, we are not there yet, but I feel like we're on the asymptote to easy to use online tools. Module banks, problem banks, material that can be put into lectures, that can be put into problem sets that are there or that we can build with some facility. But of course, teaching stays the same because whomever is teaching has to use that material thoughtfully. I call it avoiding the PowerPoint trap. You know, PowerPoint is a great program, and you can use it sparingly in your lectures, and it's really helpful. But of course, if you fill the screen with 12-point font, and you show PowerPoint after PowerPoint to your class, you've lost them. So I think the same thing is true for online tools. Faculty have to know how to use them and know how to use them thoughtfully. As the online tools become better, I have found myself thinking about myself more as a global educator as well as a local educator. And I really like that notion of bridging the space from MIT to the space elsewhere. I think mostly about Africa, but the sense of being, in addition to an MIT faculty member, a member of the Global Academy. So let me tell you about a few things that I work on to exemplify some of the notions I've told you about. One of the things that is in the conceptual stage, and it's been there for a while because it's a big project, is something called Frontiers in Developmental Biology. It's an MITx course, and it's been in the conceptual stage because it's very ambitious. It involves multiple faculty, and it involves capturing the scholarship of many of my colleagues who think about things like stem cells, cancer as a developmental disease, the cycle of life, and sex determination, and various really complicated topics and very important topics in developmental biology. We're building this as modular with choices so people can make their own kind of outcomes. And I'll tell you now about something that is more than a concept. This is called Pre-701X, Getting Up to Speed in Biology. I teach introductory biology in the spring semester. It is a very tough course. I would say it's probably the toughest introductory biology course around. And many of our students, although they're all brilliant, come ill-prepared for the course. And do very badly. They come out with a D, which as a freshman means you've failed the course, or they actually failed the course. So we decided to do something about this and get them up to speed in biology. We built a boot camp. We ran it in a last IAP. It was very successful. We just have the results from the actual introductory biology course, and all of the students who took the boot camp passed, and they did quite well, and they all feel empowered, so that is awesome. We used some nice tools, some of which are not available on the MITx platform, but I hope soon will be. We used a program called Formative, which you can look up if you're not familiar with it. It was a terrific way to engage students in the middle of the lecture with online problems. And we could watch the students do the online problems and see how they were doing. And I'll tell you a bit about the type of online problems we used in a moment. But let me tell you about another personal venture. And I should say personal means that I'm involved, not that I'm only involved. These are all groups of people working together on these ventures, and of course that is part of the pleasure. A very ambitious program we're putting together is called MIT Educator. It's probably really called MIT Educator in parentheses of the future, and it involves a number of different units around MIT, including the Teaching and Learning Lab, the Office of Digital Learning, the many faculty members, and the question is, how should we teach? How should faculty teach? It's a question for ourselves. It's a question we're addressing today, but it's also a question we're addressing globally. As part of the MIT Africa initiative, we're working with a group of Tunisian faculty who have asked us, well, actually the Department of Education in Tunisia has asked us to work with them to redo their life sciences education. It's a fantastic opportunity. It's a small country. The Department of Education is well run. It's run by mechanical engineers. Sanjay will like that, hey?
Of course.
Yeah. And it's a real pleasure to work with this group of faculty, and we envision expanding this and allowing the program to evolve. And then the last venture really gets back to the question of how do we allow students to get the concepts and then to put the concepts together. And Dave was talking about this at the beginning. Something that, really came home to me was looking at my daughter crying at the kitchen counter. And I said, what is the matter? And she said, I don't know how to do this chemistry problem. Okay, she's in 10th grade. So I said, well, is there an example? And she said, yes, there's an example, but it's not helping me with the problem. And I thought, this is ridiculous. This is a smart kid. And this is not, she doesn't get it. It's that there's a kind of chasm between the worked example and the one they've given her. Okay? And I started thinking about this more and was, influenced or delighted to be influenced by Sanjoy Mahajan, who thinks about scaffolded problems. And the notion with a scaffolded problem is that you really hold someone's hand through a problem and you give them the problem and the worked example, and then you give them the next problem that's almost done, but they have to just finish it. And then the next one misses out a bit more, and so they have to finish it a bit more. And sort of in a rather painless way, someone can get the concept, and then you flip it in a different way than flipping the classroom. You get the student to build the problem. And if they can build the problem, then you know that they've got the concept. And as you go through a course, you can take scaffolded problems and put them together in kind of complicated ways. But they're ways that I think are quite useful and not so traumatic for students. And the learning outcomes are quite good. We've tried some of these in introductory biology this semester. I was really impressed to see how much better the students did in the first exam, before which we'd tried scaffolded problems. We'd not done this before, but I have 12 years of grades and looking at how the students did in particular problems, so I feel qualified to comment, as to whether there was a change. And it was extraordinary to me to see how much better they got the problems on the problem sets and on the exams with the use of scaffolded problems in the recitations we give them. And so I've become really interested in building scaffolded problem banks in biology, and we're doing that both at MIT and working together with colleagues in South Africa. So, in summary, I think in my experience and looking around, I think as the educational tools evolve, faculty can evolve locally as educators, they can evolve globally as educators, with the central roles of faculty remaining there to discover, explain, challenge, encourage, guide students, and that is what I have to say to you, so thanks.
Thanks very much, Hazel. Hazel, there used to be at least a sentiment that as more and more learning moved online, faculty would become glorified TAs. Is that so bad? Is that good? What do you think?
I think it's incorrect. I think what is really true about faculty is that they're scholars, and the scholarship, is delightful. When I sit in my colleagues' lectures, I'm always so pleased to be there because even at the introductory level, the scholarship kind of comes through, and the students get it. So I think, actually, I don't quite understand your question, really.
Well, I think a lot of people felt it would de-skill their jobs.
No, I think so. I would say that it sort of maybe downgrades the TAs, because I think, there are some absolutely extraordinary TAs that I've worked with. But I don't think it's true. I think, let me just say, I think faculty sometimes get lazy, You get your course set up, and you go and teach it, and you teach it, and you teach it, and you teach it, and it works, and you don't have to put that much effort into redoing it every year. I think that is an issue, and I think faculty should not be allowed to do that.
I used to say, maybe I can say it in this room and get away with it. We put an X after everything, MIT X, edX. Either you'll be a Professor X or you'll be an ex-professor. Sorry, bad joke. But anyway, thanks very much, Hazel. So, Christine, you've been in this very influential role at MIT. You were also part of the task force that looked at the future of education at MIT. And now you're off to do something exciting and different. Tell us all about it.
Sure. So I thought I would start with just a few minutes on our sort of plans and state of thinking at this point, and then sort of I have 4 things that regarding the future of the faculty that we're thinking about incorporating into this. So as you heard, I'm going to be stepping down July 1st. I've been at MIT 17 years and as in my role for 6 years, and we're going to be attempting to start a new university. And there's 2 components to that. One is basically a redesign, a systemic look at a redesign of the residential research university. So looking at all interrelated aspects from the education, the curricula, the pedagogy, the research structure, the financial model, the infrastructure, everything, because it's all related in some way. And that's the first thing. And so our thoughts are really focused on project-based learning and having that built out as the main pedagogy, transdisciplinary education and research, and focused on building learning pathways that are at emerging interfaces between disciplines. So one is sort of the structure itself, and then the second part, which we're all really excited about, is thinking about access and scalability and how we can create a dynamic model that's scalable across the country, hopefully. And then that, of course, goes down to a number of things, the financial model of the university as well as infrastructure and the whole structure itself, the business model of it. So we really want to think about how we can scale and serve underserved, underprivileged, underrepresented populations. And so those are the 2 things that we're really focused on right now. Again, and also our interest in terms of the co-founders of the university is on the real interface between technology and humanity and those fields, emerging fields that really bridge those two lines. So the things that I've taken from that really impacted me and some of the work that we've done at MIT, there are 4 in terms of the future of the faculty. One is really in thinking about this sort of continuous project-based model. You know, of course, graduate education is project-based. And there are many models at the undergrad level which are project-based. We've been looking really closely at many of them. Is sort of that mentoring as a pedagogy, and how do we elevate the whole idea of mentoring as a very assessed, educate ourselves on best practices in terms of learning via mentoring. So at MIT, we have a big center. It's called funded by the Sloan Foundation, called the Center for Exemplary Mentoring. And we've been looking at, so how do you sort of educate ourselves as faculty in all the different facets of mentoring, so the technical, the learning, the assessment, psychosocial, interpersonal, self-assessments, international students, all of these different things. And so that's one thing that for us is going to be core to how we, how that is actually a form of pedagogy. And there's many best practices that have emerged throughout our work at MIT in terms of structures of communications, of feedback, ethics, policies, all different types of things, the benefits of cohorts of mentors, et cetera. So that's one thing. What's the future there? And do those roles need to be unbundled in some way as we think about assembling a board of advisors for students or cohorts of mentors? And the second thing I would say, which is relative to the access and scalability, is what are new scalable instructional models that include the residential aspects, so face-to-face aspect. How do we scale? Because in our model, we are definitely thinking of a core face-to-face project-based model on the ground with virtual learning pathways. So how do we create scalable and tiered instructional models that are lower cost but still very high quality? And one of those, there's been a number of discussions, and we're putting together groups to sort of look at this nationally, to think about, and there's a number of others as well, looking at this of how these tiered instructional models can foster peer learning in a way that's scalable. So that's the second thing. And then one of my favorites, which throughout my time as dean we've had a lot of time to think about, is how do we create transdisciplinary learning pathways and curriculum which result in truly integrated thinking, where it's not just a mesh of, you're just doubling the requirements for 2 degrees, or you're just taking a degree in a minor, or it's just not just a hodgepodge of different things. And there are many interesting models across the country. Some have emerged from the IGERT program. But still, those are, I would say, in relatively nascent stages of thinking about all the different sort of pedagogical components that can be put together to create new sort of topologies of knowledge for our students that result in this integrated thinking. And it's not just, taking courses from one discipline and another discipline and just, mixing them all together, right? There's integrations and, kind of what was said before about integrative concepts and cross-cutting activities. And there's been a lot of pedagogical elements in graduate education that have had some success in that area. So cross-cutting, interdisciplinary teams, capstone team projects in addition to the depth of the thesis, shared exploratory lab spaces, all different types of things there. And then the last area, which was raised, which I totally agree with, and we've been thinking about, is this sustainability and assessment. So one question I would ask that as we're starting to design our pilot programs is, how do you sort of transfer the great data from learning analytics in MOOCs? Could you do that with a face-to-face ground by instrumenting students? So getting dynamic assessment data, not only on learning of knowledge, but actually tracking in sort of project-based, discovery-based, generative ones, the actual generation of knowledge in a very dynamic fashion so that you can constantly iterate. And how do you apply that iterative and continuous improvement, that culture of not just summative formative assessment, but continuous dynamic assessment to face-to-face on the ground? And that's what we're actually developing into a lot of our pilots. So I think those are the four things we've been thinking about.
Terrific. Thanks very much, Christine.
Yeah.
So we have about 10 to 15 minutes for questions. If you have any questions, if you wouldn't mind it, if you could just come to the mic. I have one question. If you don't mind, if you can just come to the mic so you can ask from the mic. One question, Christine, from the Department of Fish or Fowl.
Yeah.
How do you do integrated teaching? You're a material scientist. We have a biologist. We have someone from the Department of Aeronautical and Astronautical Engineering, Mechanical Engineering. How does the student, one of the themes that's come across, you said it, to some extent you said it, Hazel, and certainly you said it, Christine, is students get nuggets, but they don't know how to, or Lego blocks, but they don't know how to build things out of them. How do we do that?
Yeah. So I think there's a couple ways that we're thinking of. First thing is when you have a very interdisciplinary subject, like my area, for example, you have to sort of map out all the conceptual pathways, right, that you need. So that's the first thing, is creating these curricular maps, right, learning pathways. And then ensuring that they all are coherent, but then also having some integrative classes, for about lack of a better word, I don't know if this is going to be a new word, that actually foster that integration throughout the whole thing. So there's a couple things. It's really creating coherent transdisciplinary pathways, and then being able to integrate that whole thing as it goes through. So
the structural mechanics of flying zebrafish would integrate all three of you.
Yeah.
Right?
Yeah.
Jaya?
So thank you for assuring us that the faculty role is quite valuable, which
Thank heavens.
highlighted in the MIT report as well. So I want to start by saying, Dr. Darmofal, it was great that you defined the problem so well about flipped learning. So it's not something radically new. This has been going on for a long time. But this assumption that we can tell students, we give them the reading, and if you do this and come to class, then we can have a great discussion. But that's a little bit simplistic notion, because there's a very complex learning scenario there about what happens there and the difficulty of facilitating that conversation in the classroom. Because I'm not talking about reading John Locke, but even other kinds of texts. If I don't know how to process a text for critical reading, it becomes a challenge. But then it was great to learn from Dr. Sive, in a very concrete way. The pedagogical design of the task is extremely important. So you had some great ideas there. So I'm trying to take that from the micro level to what MIT is doing at a macro level in a global, right? So between, let's say, US and South Africa, for example, in the US, we have clear ADA policies. People can go and ask for accommodations and things like that. So I'm making it a very, very complex scenario. So there's the heterogeneous classroom, and then there's also students with disabilities and things that we want to address. It becomes so difficult. And then there's people coming from other countries that we don't even have such policies. They don't know to ask for this. So when you're teaching at a global level in an online setting, I'm just trying to think, what is MIT's thinking? What are some of the things that's going on in your discussion? And if you can throw some light on that. And the role of affect as well. So I'm putting a lot of things there.
Maybe I'll just speak quickly about ADA. We take that very seriously. By the way, how many of you know about, of course you know about OpenCourseWare, I'm assuming, right? So OpenCourseWare has reached 200 million people in its history. So we've had to think about these issues. Cease, should I see Cease here? There's Cease. Cease heads up both OpenCourseWare and MITx back there. And she's had to think of these issues, and we've evolved philosophies around it. And it's a learning process, right? And over time, we'll get better at it. How do you caption, the bust of Socrates that I showed? How do you get, so for example, all our videos have transcripts. So we I think the whole world is trying to figure out how to best accommodate the greatest diversity of students. But cultural and preparedness, diversity, the importance of affect, Hazel, how do you deal with that?
Well, there's here and there's online. I'm a big believer in a conversation, a welcoming conversation. Tell me who you are. Let me tell you who we are. Let's talk about how we can best get you through the material. I think that works here in my classroom. Who are you? Are you from somewhere far away and you have no idea really how MIT works or how US education works? And we have ways to engage students in that sense. I really like the notion of doing the same thing with global learners. Who are you? What challenges might you have? This is how I'm thinking about your learning. Tell me about yourself. How are you thinking about yourself? I feel like, one of the wonderful things about education, it's really the part I like, is that there's a dialogue. And I think, for me, keeping that dialogue going, whether it's in a large class of 350 students who I had this semester, or a small class of 20 next semester, or through an MITx course, I think there's a dialogue there. And that, that is a somewhat vague answer, but I think it's substantive. You have to ask. You have to try to encourage people to tell you about themselves. And then you are in a better position to try to get the material across to the greatest number of learners. But I think it is, we shouldn't diminish the challenge. I just had a student in the course I just finished who had not come forward for help the entire semester, although at the beginning of every lecture, I encouraged students to come forward and email me, and my email address was big on the screen. Email me if you need some help. The student didn't. They didn't get through the course, and it turned out they were international, and they were embarrassed to come forward. So, we have these issues right here on campus, even when it's being said. So I think we can't diminish, and I think there's probably no, panacea that will kit everything, which is why, in my opinion, a dialogue is the
And maybe
way
I'll
to
add
go.
3 quick things. One is active learning helps,
Yep.
because you get to know the students. John Belcher, the pioneer who created TEAL, the Technology-Enhanced Active Learning Classroom at MIT, says, I want to look every student in the eye. So that's one. Mm-hmm. The second is anonymity strangely helps. We're doing a small pilot right now to see if anonymous questions can be used to tease out without really putting the person on a stage, right? And so online helps in that regard. And the third is the gaming industry is really figured out, right? Video games, for example. You have a level. If you start at an advanced level, you don't do well, it bumps you down and then it scaffolds you back up. So that's another thing we're thinking about. Right now, the pantry is a little thin. We don't have that many courses. But once there's a plethora of courses of different levels, maybe that'll become easier to do. But right now, we're bringing it up as we go, I would say, right? So,
Okay, here is my question, and I will start with a little joke. I hope nobody will get offended. Well, we say that when MIT designs a new massive open online course, 10 professors in the world lose their jobs. So, my question is to all the three speakers. What would be your advice? If you want to give one, what would be your piece of advice to the colleagues, like global colleagues all over the world from non-top universities? Would it be better to copy the best educational practices from the best universities, because right now we are in global competition, or would it be better to try developing our own way, our own ideas? Or any other strategies. So what would you recommend? Thank you.
So maybe we should start with Hazel, because
Sure.
you span
I have a
continents.
one-word answer. Yes. I think, you can try anything, and it's good. It is my opinion, that there's nothing, if you actually have a class of students in front of you, that is still a terrific way to communicate. I think human beings are still, communicators and that work well in person. And I was reading, an article about Snapchat in the Times yesterday, okay? And the reason that Snapchat is so popular is that it's kind of like person-to-person communication. It's ephemeral. You say something and it's gone. And I thought there was a really interesting commentary there on this kind of online and the depersonalization of things. I think, it is up to faculty to rise to the challenge of the offerings that are available. We have had for many years really extensive textbooks. In introductory biology, I have a stack like this in my office, most of which are still in their plastic, But some of them I use, and they're pretty good. And you have to figure out how to use the textbook in your course. I think the same thing is true with MOOCs and online material. How are you going to use it in your course? One of the things that's fantastic about both textbooks and online courses is that you get the scholarship of colleagues, either through the publishers or through the MOOC directly. And that's terrific. One doesn't know everything about everything. And so using that in a course is terrific. Should you, defer to MIT for all your courses and not build your own? Absolutely not. I think if it makes sense to you to build something that works for your particular topic, for your particular country, for the particular challenges that you would like your students to be apprised of, I think that's fantastic. So for me, the conceptual notion hasn't really changed that much. It's how you use the material that is the offering that really has changed. That really is the sort of the constant. It's the material changes, but it's how you use the material. And I think that is really something that we've always had to grapple with as faculty, as teachers.
And I dread the day that I think we're all exactly the same. I hope that never happens.
Yep.
And in fact, there's a field of research called situated cognition. It's popular in some circles, not in some circles, but they did an experiment in Brazil where they were trying to teach math with fruit, I think the children of fruit sellers, and they found that if they put it in the form of fruit selling, they got it completely, in fact, very quickly. And if you put it in some abstract term, they didn't. So there's a fascinating amount of research in that. Maria Klawe, who's a great educator, and her group, they've done some really great work in situating computer science education in words that are especially friendly to young women. And so I think there's a lot of opportunity for situating cognition. And I think we all ought to do it. Maybe we can take one more question, ma'am.
Hi. I wanted to know your opinion on peer evaluation. I know it works in, well, I don't know if it really works, but it's probably helpful when the class size is really huge and probably when it's a MOOC or it's an online course and there are, I guess, some 2,000 students or something like that. But do you think the assessment would really be that informative or qualitative in those cases?
In small class sizes?
No.
Or in big classes?
In big class sizes, when there's peer evaluation, like the time for feedback is lowered, but I'm not sure if the assessment will be qualitative or informative.
We use it extensively. We use it both in small classrooms at MIT, where students write papers and other students grade them. And that turns out to be an extremely powerful learning mechanism. But we also use it in edX. So we use peer evaluation extensively in edX to grade, for example, essays or poems and things like that. And it's been very successful. You do need a class size. In fact, the founder of Coursera, Daphne Kohler, has a very nice paper on picking peers to do good evaluation and picking a sort of a nice group. Have you done peer evaluation in your courses, Christine or Dave? It's very fascinating. We live by this, right? Because of our papers. Right. Peer evaluation is how we publish our papers. So we love it, I think, intellectually. But it's a very powerful mechanism, both in the small class size and in the big class size. Terrific. We are now, it is now on the dot 6:15. We have a reception out in the Sandberg Center, which is about a 12, 13-minute walk. I've clocked it many times. So we will let you all get there. I just wanted to say again, that, as I said earlier, that one of the great pleasures of being at MIT is to have within a 12-minute walk, just an extraordinary set of colleagues who, of course, are thoughtful and scholars, but also, as you can tell, care very, very deeply and very sincerely about learning. So I hope you've learned from us what we think the future of faculty is. I think as a community, as a global community, we need to define a collective view of what the future of a faculty member is. And the good news is, I think my view is that, personally, is that the role of the faculty member will only be enriched by online. For those who think it will somehow de-skill us, I think we're missing the point. So thank you very much. Thank you for your partnership.